you mentioned a number of times the importance of performing good preventative maintenance on engines equipped with diesel retrofits. Would you expand on that?
I'd be happy to. To review a bit, DPFs trap soot particles extremely well. However, at some point, that trapped soot must be combusted in a controlled way so that the DPF does not plug up. This combustion process is referred to as regeneration, and depending on the DPF design, this can be carried out passively during the engine's normal operation, or it can be actively carried out at discrete times either on board, during engine operation, or off the engine when the engine is inactive. When the particulate is combusted, residual ash is left over, and eventually that ash must be physically cleaned from the DPF.
So what goes into the DPF must sooner or later come out, right?
Well, that's a good way to look at it. The DPF must be able to balance the amount of soot coming in with its ability to combust the soot away. DPFs are designed for individual engine families having known particulate emission levels according to ARB engine certification records. However, if an engine is emitting excessive soot because of an engine maintenance problem, the DPF will not be able to keep up with combusting all that soot, and ultimately will either plug up or the internal substrate may crack due to the very high temperatures of uncontrolled regeneration. DPFs will also plug up if the engine lube oil consumption is excessive.
So what do I need to do to my engines to prevent DPF plugging and cracking?
There are a number of important things, and engine manufacturers and DPF manufacturers may have other engine maintenance practices to recommend as well. The essential maintenance practices include repair bad turbochargers, bad fuel injectors, and any other bad engine components that can cause high smoke and particulate emissions. Replace failed air intake filters. Monitor lube oil consumption closely to ensure compliance with the engine manufacturer's specifications. Possibly monitor engine wear by conducting analysis for metals in the lube oil during oil changes. If lube oil consumption is excessive, repair all bad components, which may include high-pressure oil-driven fuel injectors, valves, piston rings, etc. Monitor coolant consumption and repair any internal engine coolant leaks, as coolant may deposit on the DPF walls.
Now I understand monitoring lube oil and coolant consumption, but we normally don't know if, for example, injectors are going bad until we see lots of black smoke coming out of the stack.
Since DPF will mask high smoke temporarily, you can't wait for a high smoke level to initiate a repair action. If you don't take repair action soon, you'll risk plugging up the DPF, which will eventually cause the engine to stall and not restart, or otherwise the DPF will crack. And if you ever see black smoke coming out of a DPF equipped engine, that DPF substrate has likely cracked and must be replaced. There's no warranty coverage for engine-induced DPF failures. So watching for high smoke to initiate engine maintenance is out. Instead, your engine manufacturer will have recommended schedule, preventative maintenance procedures, which should be strictly followed. Depending on the manufacturer, there are a number of diagnostic procedures for detecting malfunctioning fuel injectors, for example. Those procedures typically involve connecting a laptop to the engine's electronic control module and activating such diagnostic programs as injector cutoff tests, injector rail pressure tests, and others. Many fleets also utilize oil analysis procedures. Oil analysis can reveal such problems as excessive fuel in the lube oil and engine coolant in the oil. Oil analysis can be performed at regular oil change intervals. Your retrofit manufacturer may also have recommended engine diagnostic procedures. One engine diagnostics method would be to monitor the exhaust back pressure of your engine by noting any alarm occurrences. If the engine is suddenly having frequent DPF alarm occurrences due to high back pressure, this condition is likely caused by excessive particulate hampering the regeneration. Instruct your engine operators, drivers, and fleet dispatchers to never ignore DPF alarms. As you can see, there are several ways to identify and remedy engine problems to ensure that your retrofits operate properly.
Are there any other precautions to take in my fleet operations?
Well, only use ultra-low sulfur fuel in your retrofitted engines. Consider using low sulfur, low ash lube oil in your engines to possibly extend the intervals between DPF ash cleanings. Never dispose of any waste oil in your diesel fuel supply tanks. Do not use fuel additives of any type in your engines unless they are specifically approved for your retrofit. Consult the ARB executive orders applying your retrofits and engine families to see what blend of biodiesel fuels, if any, are compatible with your devices, along with any other special requirements that they must meet.
We've talked about engine maintenance. What kind of maintenance do retrofit devices need?
It will depend on the type of device you have, but for most retrofits, generally the only significant periodic maintenance is ash cleaning, and that should not have to happen very often. However, if you find the need to clean a passive filter frequently, then something is wrong with the regeneration process. If you change the way you use your engine, such as change the duty cycle of your engine, the exhaust temperature may now be too low to achieve adequate regeneration for your passive DPF. So keep in mind that ash cleaning should be needed only infrequently.
Can I simply blow the ash out of the retrofit with pressurized air? Or how about turning the retrofit around on my engine and blow the ash out with the exhaust?
Do not blow the ash in the atmosphere with pressurized air. Retrofit ash is a hazardous waste in California and must be handled as such. Since diesel exhaust contains toxic air contaminants, it follows that toxic contaminants will be present in the residual ash, right? You don't want anyone breathing that waste in your shop. There are certain ash cleaning machines that involve using pressurized air to blow ash into a vacuum system that collects the ash in bags. These machines should be used with caution. Instead, it is highly recommended that totally enclosed cleaning machines be utilized. As for turning the retrofit around on your engine, it would defeat the purpose of the retrofit to blow the accumulated ash out through the exhaust pipe, so that is not allowed. In fact, retrofit devices must now be designed to prevent this.
So what's the proper way to clean ash from a retrofit?
The retrofit must be removed from the engine and placed in a special cleaning machine. There are many on the market. Some machines are developed outside of California, so if a manufacturer recommends using a cleaning method that allows the ash into the air, this practice is not allowed in California due to the ash being classified as hazardous waste. When a retrofit is removed for cleaning, the engine cannot be operated. After cleaning, the DPF core must come back to the original engine or group of engines using the same device in your fleet. Sometimes fleet purchase an extra core to be installed in its place in order to minimize downtime. Engine downtime can also be minimized by selecting where your retrofit is to be cleaned. The three possibilities are in your own shop, using a local DPF cleaning service, or shipping the DPF to a remote site for cleaning.
So what are the steps to clean out a DPF in a machine?
There are several types of cleaning machines. One type applies vacuum to the DPF in an airtight enclosure and sucks the ash into special bags that are sealed and removed to a hazardous waste dump facility. This type of cleaning is usually sufficient for DPFs used on recent model engines with dry particulate and ash, and this operation can usually be performed quickly. Another type of cleaning machine applies vacuum, heat, and vacuum to combust and suck out any oily ash from DPFs used on older engines. By necessity, this is a more time-consuming process. In either case, the cleaning machine must measure the pressure drop through the filter after the cleaning to make sure it has been sufficiently cleaned.
Would it make sense to get my own cleaning machine to minimize downtime?
It might, but there are some important things to consider first. In California, you would become classified as a hazardous waste generator and must obtain a permit from DTSC. You must obtain a cleaning machine that meets OSHA standards, and it needs to verify when the DPF is completely clean. Additionally, a cleaning machine is an air toxic source which may require an air permit from your local air agency. And finally, any removal of the DPF must follow the manufacturer's procedures, or you may lose your warranty.
Those are important points to think about, thanks. But how often must a DPF be cleaned?
It basically depends on how often your engine is operating and if its particulate levels are low or high. The more particulate that enters the DPF, the more frequently it will need to be cleaned. A rule of thumb is once per year, but that can vary. Your retrofit manufacturer may have more specific information. In addition, some manufacturers have strict cleaning requirements in order for your retrofit warranty to remain valid.
I understand that DPFs are equipped with warning alarms. How do they work, and what can cause them to go off?
DPF alarms basically monitor the engine exhaust back pressure just ahead of the DPF. Such monitoring is necessary to ensure that the regeneration process is occurring normally. Some DPF systems have a two-step warning light process. Other systems may only have a single warning light. On two-step systems, an amber light may illuminate, at first indicating that corrective action should be taken soon. In a two-step alarm, the second alarm will likely be a red light that indicates a higher back pressure problem that needs urgent attention. This would necessitate that the engine be shut down as soon as safely possible and corrective action taken. An advantage of a two-step alarm system is that when the amber light illuminates, it may allow the engine to complete its work operation before corrective action would need to be taken. If the amber light is ignored for too long, however, the problem may worsen and the red light will illuminate, indicating an immediate engine shutdown. To avoid unexpected work shutdowns, it pays to act on the problem quickly and before the red light illuminates.
So what do we do when the alarm goes off?
All DPF operational manuals should contain a troubleshooting guide, and it is best to consult your manual to approach the troubleshooting in a systematic manner. In rare cases, the alarm light itself may be malfunctioning, but most retrofit manufacturers have diagnostics to detect that problem. If there is a malfunctioning alarm light, you should consult your manufacturer right away to correct it in order to avoid possibly receiving a citation by an inspector. One thing that is not the correct fix if an alarm is activated frequently is to just clean the DPF. Cleaning a DPF every few weeks, for example, is not a substitute for proper regeneration. The root cause of the inadequate regeneration must be diagnosed and corrective actions implemented. In that case, you would need to work with your manufacturer to determine the cause of the problem. You should also work with the manufacturer for any alarm problems that you cannot remedy. The retrofit manufacturer is your key resource.
So when an alarm is activated, the DPF shouldn't be just automatically assumed to be the problem. We probably shouldn't just yank the DPF off the engine either, right?
Absolutely not. Once retrofitted, engines are not allowed to operate without their retrofit devices, as they would be subject to enforcement citations, and the devices should not be bypassed in any way. Some retrofit devices have diagnostic caps that can be removed for servicing purposes only. Other than for servicing, you should never operate your engines with those caps or plugs removed. In these cases, you would be subject to enforcement citations and penalties, and always remember to check for any exhaust leaks. One last comment about DPF alarms. Train your engine operators, drivers, fleet dispatchers, and mechanics that these alarms should never be ignored. The first thing an engine operator should do when starting the engine each day is to check the DPF alarm, and check it at the end of the day too. Any problems should be immediately reported to the supervisor, and under no circumstances should the alarm be disconnected by anyone. As fleet administrator, it is your responsibility to inform and enforce these requirements to all affected staff.
I can really see that I have to be closely involved with my fleet's engine practices.
After we take a break, let's cover the retrofit program enforcement and how you should comply with the program.
Be sure to watch the remaining video modules in this series, Emissions Retrofits, What Diesel Fleet Administrators Need to Know. For more information, or if you have any questions, please consult these sources of information provided by the Air Resources Board.